Okay, so we're going to have a quick look at the structure of metals. First thing to bear in mind is when you put one metal next to another, on the outside of the metals you've got electron shells. Those electron shells are going to repel each other. Let's have a look at that. So here's my atom, a bit of a wobbly atom of sodium, and it's got electrons on the outer shell, on the outside of the atom. And if I put another atom of sodium next to it, you'll find that there are electrons here and there are electrons here, so there's going to be a degree of repulsion between the metal atoms, and that doesn't fit with our understanding of how metals actually operate. We know in metals they're actually very strong, and if they're strong that must mean the atoms are held together very, very tightly. So what is the arrangement of metals? What we do is we've done some investigating in terms of the properties of metals, and we put forward this proposal. What we have here is not a metal atom, it's a metal ion. This is a sodium ion. Remember sodium being in group 1. Sodium forms a +1 ion and it releases an electron. This is another sodium atom which has lost an electron, so it's a +1 ion. This might be its electron. This is a sodium atom, it's turned into an ion and it's lost an electron. So what we've got here is an arrangement of positive ions, positive metal ions. Each of those will have lost electrons, and those electrons float between the ions. The description we have for that is as follows. So we say it's a lattice of positive ions. The lattice, we've come across that before, and we mean a lattice is horizontal rows and a nice ordered arrangement of ions. So it's a lattice of positive ions. These are my positive ions, and it's held together by a C, and the word C is meant to imply the fact that these electrons are actually all moving all the time, and the delocalized means that they're not in one place. So these electrons, again, they're moving all the time. Lattice of positive ions held together by a sea of delocalized electrons. That phrase is a really important phrase for you. How does it fit in with our understanding of metals? I won't do much on this video, but the crucial thing to say is that metals are strong. The particles are held together very, very strongly. Here we've got a positive ion and it's next to another positive ion, but remember, because these electrons are moving, these electrons actually act as glue and hold these positive ions together. So this ion here is not actually next to this ion here, but between it is an electron. So the ion is attracted to the electron that's here. This ion is also attracted to the electron which is here, and that's why it holds the whole arrangement of ions together very, very strongly. The best analogy that I can give you is the idea of these electrons being a mobile kind of glue sticking these positive ions together. So crucially, structure of metals, we've got a lattice which is a regular arrangement of positive ions held together by a sea of delocalized electrons. Sodium happens to give away 1 electron because it's in group 1. Magnesium will often give away 2 electrons, and aluminium will usually give away 3 electrons. If sodium gives away 1 electron, it will be held quite tightly to the electrons. Magnesium, if it's given away 2 electrons, it's got a 2+ charge here, and that's going to be held together more tightly by the electrons. And aluminium, if it's got a +3 charge here, it's going to be held even more tightly together. That means that sodium, strong bonds, has a high melting point. Magnesium, stronger bonds between the +2 ion and the electrons, means a higher melting point for magnesium, and aluminium would have the highest melting point of all because it's +3 ions held together by low delocalized electrons. Okay, that's it, structure of metals.